Okay, hello, good morning. Welcome to Build Day 3. My name is Craig Loewen. I'm a product manager working directly on the Windows subsystem for Linux. I also work on the Engineered for Developers team at Microsoft, and our goal is to make developing on Windows awesome, including Linux development. And I'm joined today by...
Hi, my name is Pierre Boulay. I'm a developer on the Linux on Windows team, and I work directly on WSL.
And today we want to chat to you all about the Windows subsystem for Linux and how it can be your multi-tool in your enterprise. And just to help level set, I wanted to kind of take you through a tour of the Windows subsystem for Linux really quickly if you haven't seen it before. WSL is a way for you to run your Linux tools, utilities, command line apps, GUI apps, and more, all directly on a Windows environment. And what really sets WSL apart from other Linux-based or virtualization-based approaches on Windows is that everything is integrated and feels just like the same machine. So if we have the collage on the screen, if you take a look at the left, we have some terminal windows of the different distros you can run, things like Ubuntu, OpenSUSE, and Debian. You can all run those locally on Windows. And in the middle, we have a VS Code window that is an app running in Windows, but it is directly targeting and debugging against Linux workflows. So you can run and debug all of your Linux applications using your regular Windows flows. And then on the right, we have a sample of a GUI app running on Windows. For those of you with sharp eyes, you will notice the GTK3 tiling at the top. So that is a real Linux GUI app, and it runs just like a regular window in Windows, even down to the drop shadow, Alt-Tab, taskbar integration, and start menu integration. And so really our goal on the team is to make it as best of an environment possible for you to get your work done on Linux, even on Windows. And so today, what we want to do is take you through the latest improvements for the Windows subsystem for Linux, how we're improving it for you. We want to take you through WSL Zero Trust, how WSL is built on Zero Trust principles to be secure in your enterprise environment, and all the new integrations with Windows and how we're broadening the impact of WSL beyond just the exact code base, but you're also going to see it in other products here at Microsoft Build. So I'm going to pass it over to Pierre, who's going to take us to the latest improvements on WSL.
Thank you, Craig. So we have a lot to talk about today. We're going to talk about memory improvement, storage improvement. We're going to talk about bare networking compatibility, and we're going to talk about network level security. So let's get started. Let's talk about memory. So under the hood, WSL runs a full Linux kernel. And as you do I/O inside of WSL, the Linux kernel is going to cache this I/O to improve performance, which is great. But it can also mean that over time, the WSL2 virtual machine is going to take more and more space on the Windows memory, so its footprint just increases over time. So we have created a new feature called Auto Memory Reclaim. So Auto Memory Reclaim is a WSL config, which is the configuration file for WSL. It's a WSL config setting. And when enabled, Auto Memory Reclaim is going to periodically detect when WSL is idle, and when so it's going to drop this cache so that this memory becomes available again in Windows. We are offering two strategies for Auto Memory Reclaim. We're offering Gradual, which will drop all of the cache when WSL becomes idle. And oh, sorry, Gradual is the option that drops part of the cache when WSL becomes idle, and Drop Cache drops all of the cache all at once when WSL is idle. With Auto Memory Reclaim, you never have to worry again about WSL's memory usage in background, so you can keep WSL running all the time, and this memory comes back to Windows when WSL is not in use anymore. Auto Memory Reclaim is enabled by default on the latest WSL build, and we recommend you to try it out, and please give us some feedback on GitHub. Okay, let's talk about storage. So WSL distributions are stored inside VHD files or virtual disks. And the way those work is that when we create the distribution, those distributions are created in disks that are allocated to a small size and that grow over time. So what this means is that as you create more files inside of WSL, the size of this file on the Windows machine will grow, which means that as you work on your project, the size of this disk is just going to increase. And when you delete these files, this space is not reclaimed to Windows. So this is why today we're going to talk about sparse VHDs. So sparse VHD is a special type of VHD that is able of reclaiming the space that is deleted inside of the Linux file system. So you can enable sparse VHD by setting sparse VHD equals true in WSL config. That will apply for new distributions. Or you can transition existing distributions with WSL-manage --set sparse. And when you do that, the space is going to be instantly reclaimed, and you're going to see the storage improvements right away. When you enable sparse VHD, you never have to worry about compacting your VHDs anymore or about WSL taking more space than it should on your Windows machine. And let's talk about networking. We have a lot of new exciting networking improvements that we're going to talk about today. We have improvements for DNS compatibility inside of WSL. We have a completely new networking mode, mirrored networking. And we're going to talk about network level security with support for Hyper-V firewall. But before that, let's look at some demos. And let's look at how auto memory reclaim works. So here we have a WSL config file with auto memory reclaim set to drop cache. And let's start WSL. And let's look at the memory footprint of WSL on the machine. So if we track the VMM WSL process, which is the process that represents the WSL virtual machine, and if we just run a command to just do a bunch of I/O, like grep, for instance, let's run a recursive grep in our home directory, when we do that, we can see that the footprint that the VMM WSL process has on the machine increases, which is expected because you're doing I/O, and the Linux kernel is going to cache this I/O. So if we accelerate the video, we can see that even though the grep process has exceeded, this memory is still allocated. If we move forward in time a little bit for when WSL is considered idle, you can see that this memory is reclaimed automatically after a while. Now you're back to the previous memory footprint of WSL doing nothing.
So Pierre, if I build all of my Docker containers, expand all that memory, then I leave my computer for a bit, it'll shrink right back down.
Yep.
Awesome.
That's exactly it. And as I was saying earlier, there's multiple strategy. You have drop cache and gradual, which you can experiment with. And you can also opt out of this feature if you prefer to keep all the cache alive. But this will significantly improve the memory footprint of WSL on your machine. And talking about improvement, let's look at sparse VHD. So let's see what happens without sparse VHD enabled first. So we have a test machine here with about 35 gigabytes of used space. And if we create a 10 gigabyte file on the disk and we accelerate the video a bit, we can see that when we look at the amount of used space again, we have now 43 gigabytes of used space, which makes sense. But now if we delete this file inside of WSL and we call sync to make sure the I/O is synced, we can see that this space is still in use on the machine. So even if we call fstream, this space is still in use. So let's shut down WSL and let's transition this distribution to a sparse VHD with WSL-manage --set sparse. And when we do that, we can see that the transition happens almost instantly. And when we start WSL again and we look at the amount of used disk space again, we can see that we are back to 35 gigabytes. So the space was reclaimed instantly. But that's not all. If we create a 10 gigabyte file again, and we run the same command again, the space is used again. And if we delete this file and sync I/O one more time, so when we call sync again, we can see that the space is automatically reclaimed. So this is what sparse VHD gives you. The space that the WSL distribution disks uses is never going to be more than what it needs again, so you never have to manually go and compact the disks by hand again.
And Pierre, that sync command, that's the thing that Linux is doing just automatically, but we ran it just so that you could get the demo and see it in progress. Okay.
Yeah, exactly, because all of this is cached, so sync makes sure that all of the I/O has happened.
Awesome.
Sparse VHD is available on Windows 11, and you can opt into it with the commands I showed earlier in the WSL config changes. Please go try it out. All right, so let's talk about networking now. And let's start by talking about DNS. So one of the things that we've improved a lot in WSL is DNS. And one of the reasons for that is that networking is a space that can have a lot of complexity. And we know that some networking configurations might cause DNS issues in WSL out of the box. So let's look at how DNS used to work in WSL. So here we have the default DNS configuration that we used to have in WSL. So we have /etsy-resolve.conf, which is the standard Linux configuration file for DNS. And what we would do is that we have an IP address that we set in this configuration file that maps to an internal resolver inside an internal network that is between Windows and WSL. This resolver will then receive the query from WSL, forward it to the actual DNS server, and return that result. So the advantage of this approach is because you are using the Windows resolution service, you are getting all of the DNS configuration that's been done within Windows in WSL. So if, for instance, you are inside of a VPN, this configuration can resolve DNS records that only exist inside of the VPN. But what we've seen is that there are things that can hinder this. For instance, it's possible for custom firewall rules or third-party security solutions to block the DNS query or response, which ends up causing a situation where you install WSL and DNS requires more work to actually get it working.
And this is happening because it's seen as a network packet, right, coming from an external machine, because WSL is virtualized at the end of the day.
Yep, that's right.
Got it.
And WSL has an IP address inside of an internal network, so it is possible to block this traffic with firewall, even if you didn't intend to.
Right.
So what we've seen some people do instead is to use an external DNS. So in this configuration, resolve.conf will get the IP address of an external DNS server, so it can be 1111.8888 or anything equivalent. And what would happen then is that the DNS packet would leave the machine, so it would traverse the NAT, and it would reach an external DNS. This approach tends to be a bit more reliable, but when you do that, you lose all of the DNS configuration that's been done on Windows. So doing something like this doesn't really give you a good solution. So this is the reason why we have introduced a new way of doing DNS, which is DNS tunneling. So in DNS tunneling, what we do is that in resolve.conf, we set a loopback IP address. So in this example, 127.0.0.42, and we start a process inside of WSL that we call the guest network service, and this process will bind this IP address on the DNS port, so port 53, and will receive the DNS request coming from WSL. When the guest network service receives a DNS request, it then sends it over an HV socket, which is a special type of socket that exists between a hypervisor and a virtual machine. So it will send this DNS query to WSL service.exe, which is the Windows side service of WSL. And then WSL service can apply all of the Windows resolution rules and talk to the actual DNS that's responsible for the record that we're looking for. So DNS tunneling gives you the best of both worlds. You have an implementation that cannot be blocked by a security solution because an HV socket is not a networking socket, so firewall rules can't block them. But if you are connected to a VPN, or if you have an advanced networking configuration, all of the Windows DNS features are available inside of WSL. DNS tunneling is currently enabled by default in the latest version of WSL on Windows 11. And if you've ever had DNS issues with WSL in the past, I strongly recommend that you try it out, and we're always happy to hear your feedback on GitHub. And if...
I don't know if that's good or bad that we're getting clapping for DNS issues.
Well, we're really hoping that this will help a lot. And if you wanted to go back to the previous mode, that's also possible. You can opt out of it if you'd like. This is all documented on our MSDN page. So talking about networking, I've just talked about how WSL runs in a NAT by default. And let's talk a bit about that. So NAT mode is the current default for WSL networking. So quickly, let's talk about what this means for processes running inside of WSL. So here we have a bunch of processes that will access the network. And in NAT mode, what we do is that we have one Linux interface, S0, running inside of WSL. And all of the processes have to use this interface to egress traffic. Then the network packets are sent towards the host networking over the internal network. And eventually, the host routing rules, so the Windows routing rules, will apply, and traffic will go through the underlying physical interface. So there are two issues with this model. So one of them is that a Linux process cannot choose which network interface it wants when it's emitting packets. So if you are connected to a VPN and you want to send a network packet specifically in the VPN in WSL, in this networking mode, it is not possible to do that. You have to follow the host networking rules. Also, because this is a NAT, if a process in WSL binds a port on the S0 interface, this port binding will not be reflected on the physical adapter at the Windows level. So this means that, for instance, if you wanted to serve a website via Nginx and you bound the port in WSL, it would not be possible for machines in your local area network to access this website unless you manually created port mapping with WSL's internal IP address, which is not a simple process. So let's talk about mirrored networking, and let's see how mirrored networking solves those problems. So when you enable mirrored networking in WSL, what's going to happen is that all of the network adapters that you have in Windows will be mirrored inside of WSL. So if we take the situation with an Ethernet adapter and a VPN adapter, both of those would be available inside of WSL. Then both of those network adapters will forward the traffic to the correct underlying physical adapter at the Windows level. So what you get here is that processes running inside of WSL can choose which network adapter they want, and if you bind the port on either of these interfaces, this port binding will be reflected on the interface at the Windows level. So with this, you can serve a website or anything else that you'd like from your local area network if you enable mirrored networking. So mirrored networking is currently opt-in. It's available on Windows 11, and you can enable it via WSL config, set networking mode equals mirrored. This is also documented on our MSDN page, and we recommend everyone that has advanced networking scenarios to go try it out, especially if you serve websites or other network traffics from WSL.
There's also some other cool features too, like the ability to have IPv6 connections is enabled with mirrored mode networking.
That's right.
The ability to access a server from Windows using localhost inside of WSL. So let's say I had a database running in Windows and I wanted to use my localhost relay to access that in WSL. I can now do that with mirrored mode. So there are other benefits beyond compatibility and serving it to your local area network as well. So please try it out and let us know what you think.
Yeah. So when we see something like this, like one of the questions that we might ask is, okay, so now I can have packets that come from outside of my machine, hit WSL directly through this port binding. So what does this mean for security? And to talk about that, a great tool that is generally available right now in Windows 11 is Hyper-V Firewall. Hyper-V Firewall is the best solution to control what type of network traffic is allowed to and from WSL. So let's see a bit how this works. So in Hyper-V Firewall, there are three types of network traffic. We have loopback traffic, which is traffic coming between a WSL process and a Windows process. It goes both ways. We have outbound traffic, when packets leave the machine coming from WSL. And we have inbound traffic, which is the other direction. With Hyper-V Firewall, you can control what rules apply to this traffic for all of these three types of traffic, and you can create rules in a very similar way to what the Windows firewall settings allow you. Let's look at what this looks like in practice. So here we have a test machine with a Windows firewall rule that's going to block github.com. So on the Windows side, if we call github.com, we can see that the traffic is properly blocked. But if we start WSL, because WSL runs in a separate network, by default, Windows firewall rules are not applied inside of WSL. So if I call github.com here, I get an answer. So let's open up WSL config, the configuration file for WSL, and let's enable Hyper-V Firewall by setting this toggle to true here. Then let's run WSL-shutdown to restart WSL. And when we do so, Hyper-V Firewall is now enabled. And if we call github.com, we can see that this traffic is blocked. And the reason for that is that by default, Hyper-V Firewall will apply all of the Windows firewall rules. But of course, we've only blocked one website, so the rest of the network traffic, like accessing Microsoft.com, is still possible. So let's look at why is that. if we look at the default Hyper-V firewall configuration, we can see that the default outbound rule is allow. So if we wanted to, let's say, block all of the outbound traffic, this is how we would do it. We would simply set this to block. And as we do this, this rule is applied instantly. When we go back to WSL, this traffic is now blocked. So this is what Hyper-V firewall allows you to do. You can have fine-grained control on what type of network traffic is allowed to leave and come into WSL. And with group policy, you can enforce that Hyper-V firewall is required to use WSL.
Can we take a look at a little bit of a more challenging example, like blocking all non-HTTPS traffic with WSL? What would that look like to set that up?
Yeah, let's see what that would look like. So this is the PowerShell command that you would use to create a rule that would block outbound traffic on port 80 coming out of WSL. So the VM creator ID is a constant GUID, and this is the GUID that maps to WSL. This is all documented on the Hyper-V firewall documentation page. And this type of rule can be deployed either via PowerShell or via group policy. So this is how you can have even finer grained control on what exactly is allowed to happen inside of the WSL virtual machine at the networking level.
And just as a reminder, this is all generally available by default on Windows 11 machines.
Yes.
So your networking rules set up on Windows Firewall are now affecting WSL to be secure by default.
Yep, that's right, sir.
Very cool.
So this is what we want to talk about today. We want to talk a bit about security. And one of the things that we know is that there are people that want to use WSL inside of the enterprise environment, but that can't because their IT admins don't allow them to. And this is one of the messages that we want you to take from this presentation today. WSL is built on the zero trust principles, and you have all of the tools to enforce company policy and network level security inside of WSL. So if you're an IT admin, this message is for you. And if you're not, go tell your IT admins.
Show them this presentation.
Yes. So let's talk about what tools WSL offers to provide security. So let's talk about Microsoft Defender Endpoint. So we are announcing the general availability of the Microsoft Defender Endpoint plugin for WSL. With this plugin, you can monitor and get alerted of threats running inside of WSL. So this is what the Microsoft Defender Endpoint plugin gives you. And when you run it, WSL is not a place where malware can go to hide. Let's talk about authentication. Let's talk about Microsoft Entra ID. We are announcing the upcoming preview release of the Microsoft Entra ID plugin for WSL. So with Entra ID inside of WSL, you are now able to connect to any Microsoft Entra ID application that you've already logged in from Windows inside of WSL seamlessly. So you don't have to authenticate again inside of WSL, and all of your accounts should be already populated. This means that if you have any Microsoft Entra ID application, so if you want to log into, let's say, Office 365, or if you have a custom Entra ID application in your enterprise, this will work without you needing to do anything because this is part of the Microsoft Authentication Library, or MSAL. And as long as you use a recent version, this would just work. And today we're also announcing the upcoming preview release of the Microsoft Intune plugin for WSL. So Intune gives you an even finer grain level of control of what's allowed to happen inside of WSL. With the Microsoft Intune plugin for WSL, you can control which distributions users are allowed to run, which versions, and in the future we're planning to add support for custom deployment script instead of Microsoft Intune. So let's look at some demos. Let's look at a scenario of a user opening a browser instead of WSL for the first time. So here we are installing Microsoft Edge running inside of WSL, and we're going to open it using WSLG. And when we open Microsoft Edge for the first time, we see that we get the out-of-box experience for Microsoft Edge. So it's the first time that we get to configure the browser and our accounts.
And this is a Linux app.
Yeah, it is a Linux app.
Very cool.
A graphical Linux app running from WSL and Windows. And here we can see our accounts already populated, and we have done no configuration here. This is just available right out of the box, and we are logged in to our Entra ID application account. And we can see that this account is properly authenticated, and we did not have to do any multi-factor authentication, input any password, or do anything like this. So this is what the Microsoft Entra ID support for WSL gives you. Seamless authentication to Microsoft Entra ID applications.
And that's all using the Microsoft Authentication Library and piping it to your Windows authentication. So the security is still there, but just by default, we're saying, hey, we know you're in WSL. Well, let's make it as easy as possible for you to use the security in Windows, just seamlessly pipe through.
Yep. And let's go a bit deeper. Let's see how we can use the Microsoft Intune support in WSL to do something a bit more advanced. So let's say that we wanted to create a compliance rule for our company policy that would restrict which distributions we want users to be able to run inside of WSL. So let's see how this would work. So we're going to create a custom script on the on the Intune Admin Center portal, and we're gonna look at the distributions that are installed on the machine. So here we have a list of the distributions that we are allowing. So we have Ubuntu 20.04 and 22.04. And what we're going to do is that we're going to iterate through the registry keys that are created by the Microsoft Intune plugin for WSL. So we're going to do that for all the users on the machine. And we're going to look at the last check-in time, so the last time that the Intune plugin saw this distribution. And based on these distributions and their version numbers, we are going to decide whether the machine is in the compliant state or not. And based on that, we're going to return compliant or not compliant. So what we're going to do is that we're going to copy the script, and we're going to paste it on the admin portal, and we are going to create a new custom script that's going to do the custom compliance policy that we want. So once we have created the script, we're going to create a new policy for Windows 10 and higher, and we're going to name this WSL compliance. And then we are going to select the custom compliance script that we have just created. So we're going to go here and pick the script. And then we are going to have a rule that's going to look at the output of the script. And it's only going to consider the machine compliant if the output of the script is compliant. So now we are creating this company policy. We are going to apply it to the group of WSL users, which we are a part of. And once we've done that, as we deploy this policy, we can go on a test machine and see how this policy affects the compliance status of the machine. So if we go on our test machine and we refresh the compliance status, we can see that none of this policy is in effect. We are not able to access company resources anymore because our machine is in violation of this company policy. And if we look at this message, we can see the WSL distributions are not in compliance. So as a user, what we can do is, oh, OK, let's look at the distributions I have installed. And we can see, oh, this person has Ubuntu 18.04, which is in violation of company policy. So what we can do is unregister it with WSL-unregister. And this unregistration is going to be received by the Intune plugin. And when we refresh the compliance policy of the machine, we can see that we can now access company resources. So this is what... Thank you. This is what you can do with the Intune support for WSL. With this, you get even finer grain support, and a finer grain control support on when your users can have access to company resources, under which condition they can access the company resources.
This is kind of like a chocolate and peanut butter better together story, because the demo we showed before this was how we are accessing Entra ID integrated with Windows and Linux. And so now when your machine is non-compliant on Windows or Linux, your access to protected company resources is protected in both environments. And you as an administrator just have to focus on making sure the device overall is compliant or not compliant to affect these. So you don't have to worry about the intricacies of moving this between Linux or Windows. It's highly integrated.
That's right, sir. So I've just talked about 3 new plugins for WSL. Let's talk a bit about how exactly this works. So all of those, so the Microsoft Entra ID plugin, the Microsoft Intune plugin, and the Microsoft Defender Endpoint plugin are built on top of a new plugin infrastructure that we have created for WSL. So under the hood, WSL runs as a Windows service, WSL service.exe, and the service controls a virtual machine. This virtual machine has mount points and processes, And inside of that, we have namespaces, and each namespace is a distribution, and each namespace has its own mount point and its own processes. So when a plugin is installed on a machine, a plugin can be installed by editing a registry key that is only writable by administrators, and plugins require signatures to be installed. And so when a new plugin is installed, this plugin is loaded by our service and is then offered an API that allows it to interact with the virtual machine. So this means that a plugin can run processes, run commands, look at their outputs, look at the file, list the distributions that are installed, and based on that, the plugin can get signals on what's happening inside of WSL and modify its behavior.
And one of the cool things about this is that plugin is running not in the namespace of the actual WSL distro for the user. So what that means is, despite having sudo access in your WSL distros, if a user wanted to try and find this process and kill -9 to stop the Linux Intune agent, they would not be able to do so because they can't break out of that namespace that they're in for their WSL distro. The only way to affect this plugin behavior is by having Windows administrator access on the machine.
That's right. And the WSL plugin interface is public and documented, and we have a demo plugin that you can try out and modify for yourself. So we encourage you to go and write your own plugins. So I've just talked about a lot of things. I've talked about memory improvement, storage improvement. We've talked about better DNS compatibility, about a new networking mode, and how WSL is built on the zero trust principles. But that's not all. WSL is getting an even better integration with Windows. Take it away, Greg.
Thank you. So Pierre did a wonderful job of showing all the ways that we are improving WSL directly on the product itself. But as he said, that's not all. We also have awesome integrations coming to the Windows subsystem for Linux that might not necessarily be part of the WSL code base itself. So coming soon, we have a new WSL feature of a WSL settings app. So a graphical app that will help you manage and interface with all of those settings that Pierre showed. And then we also have the ability to manage your WSL distros with the 𝗦𝗲𝗀𝗀𝗀𝗀 application. I'd like to give credit to Carlos Ramirez from 𝗦𝗽𝗲𝗀𝗀𝗀𝗀 This was an open source, basically community-driven feature that we are consuming inside of DevHub, inside of 𝗦𝗲𝗀𝗀𝗀𝗀, and are working to integrate it by default. On top of that, we have other experiences in the Windows operating system that are built on and using the Windows subsystem for Linux. If you've seen the VS Code AI toolkit that was announced this week that directly uses WSL, you can use that to fine-tune small language models directly on your device. And immediately after this, there is a session 0 to Hero that I'm doing that shows that exact workflow. And on top of that, Windows Package Manager, or winget, now supports installing the Windows subsystem for Linux. And so you can use that winget configure and other winget scripts to set up WSL inside of your enterprise or just directly on your machine. And so I want to take you through these demos in my favorite way, which is showing them live with some running code. So let's go to my machine, and I'm going to put the brightness up a little bit for me. And what we're going to do is start off with winget. So let's take a look at how we made that improvement. If you haven't seen winget before, it is a package manager on Windows. It works just like how you would use package managers other places on Mac or Linux. And you can do things like winget search WSL, for example. And then it will take all of the packages matching to the Windows subsystem for Linux, or WSL, in its winget repository and show them to you. And you'll see that there is a moniker for WSL here, and we've added this Microsoft.WSL solution. Why did we add it, and what did we add to make this possible? Well, WSL depends on Windows components. And so if you go and run winget show Microsoft.WSL, you can see all of the necessary information, like the installer URL, the install notes, change release notes, etc. But I want to draw your attention to these dependencies section down here. We actually are able to say that WSL is dependent on some Windows features. When you enable WSL, we enable the Windows subsystem for Linux optional component for you. And we also enable the virtual machine platform optional component. And so this means you can run the winget install Microsoft.WSL. It will require admin to enable these features. You can run that on your machine. It will say, hey, I'm going to install these features for you. You restart, and then you'll have full WSL access after running it again. And so that's feature number one. Let's take a look at how we can help manage WSL with a WSL settings application. So the way that we do settings right now in WSL is using this .wsl config file. And this is great. Don't get me wrong. I love Linux-based text edit for settings, and Pierre does too.
Yep.
But we wanted to make a GUI version of this because there's some things that this has challenges with. For example, if I didn't know about this networking mode equals mirrored command, how would I know to put this on if I hadn't seen this talk or didn't see any of the docs for it? It's a little bit hard to discover new features. It's hard to know what's enabled by default on your machine. And so that's why we've made this settings application. So I'm going to run it. I'm going to use PowerToys Run if you haven't seen it before, but you'll be able to access it from your Start menu. I'm running an early debug build of this. That's why it's 𝗦𝗲𝗀𝗀𝗀𝗀🐶.exe. But this will show up just like any other app on your machine. And I'm going to go ahead and just start this process up. And I seem to have frozen this, which is OK. Let's go to my Start menu and try 𝗦𝗲𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 that will have the list of all the settings available on your device. And we've sorted it on the side. So we have memory and processor, file system, networking. You will be able to see the defaults on your machine. So despite not configuring processor count, I can see it's 20, which is the same as the amount of processors I have on Windows. And I can go through and explore some of these features. I really recommend that you take a look at things like the networking tab to try out some of these new networking modes. And I can see that on my machine, DNS tunneling, some of the features we talked about are enabled by default. So getting a view like this should really help you understand what's available in WSL. On top of that, we have optional features like enabling or disabling GUI applications, nested virtualization, and more. And so if I go ahead and change some of these, like I'm going to change my processor count to, let's change it to 18, for example, to decrease the amount of resources that WSL has available to it. And I go and close this application. If I run cat.wslconfig, it's updated that .wslconfig file. So really the goal here is you can use either or. The text editor, you can use the GUI editor. We want you to be able to be empowered to use both. And we hope that it improves your experience, especially as we add more interesting settings inside of WSL. And now let's take a look at DevHome and see how we can manage WSL distros using a graphical application. So if you haven't heard of DevHome, it is a companion app that helps you as a developer get your work done. And it has a lot of interesting features on the side. There's a new one that we've added this week called Environments. If I go ahead and click that, I get this page that shows me all of the different environments where I might do my development. And so this includes things like Hyper-V virtual machines. It includes Microsoft DevBox, early build, so please excuse that. And it also includes a this is my personal insider machine, and so that's why we're seeing a lot of these as I've been running demos all week. But here we go. Despite that error, it's shown up, and so we have my Microsoft DevBox is shown here, as well as all of my WSL distributions. And I can go ahead and launch into these. And what's great about that is when I launch this, it uses my actual terminal profile for Ubuntu. I can go and terminate these distributions. I can uninstall them. And so let's go ahead and uninstall Debian. Sorry, Debian. Let's pull it back. I can go up to Create Environment. And I have one spot where I can create some different developer environments that might interest me, like DevBox, Hyper-V. I'm going to choose WSL. And then I'm going to see all the distributions that are available for me. I'm going to pick Debian as one. And then I'm going to create this environment. From here, it is going to start the WSL install process. I already have the AppX on my machine. And so that part was instant. And then I can just set up my user account and get access to WSL right away. And so the goal of this feature is we want it to be an approachable and easy way for you to manage WSL and all of your other developer environments on Windows. Again, I'd like to shout out Carlos Ramirez. This was developed by him from Whitewater Foundry. And we're going to show some links of how you can get access to it today. We're working on integrating it into DevHome by default. And so the other thing I mentioned was the ability to run some AI workloads with WSL. I want to show you an experimental feature in DevHome that is built on WSL and allows you to do something kind of, I think, pretty cool. If you go to Settings, Experimental Features, you'll see this Quick Start Playground option right here. You're going to enable that and turn that on. And then once you go to the machine config page, there's a new Quick Start Playground option. This is an experimental feature that we've added. We are exploring ways that we can help AI be used in your actual developer workflows. So For example, if I'm a developer and someone said, I need you to create a tic-tac-toe game, let's say GUI for sure. And so I'll type that in, and I'm going to hit generate. From here, we're actually calling into OpenAI, and it is generating a Linux developer container definition for us. And so we're taking the output, and we're showing it some examples of how to build these different containers. And then we're also building some sample code. So you can see it's getting container files for environment. And this is a live demo to the actual OpenAI calls. So we're going to see how it goes. AI is something that doesn't always give you the answers that you predict. And so the goal of this use case is that we want it to be a playground for you to explore different developer tools, applications, or ideas that you might have. Before this talk, I was warned that OpenAI is having outages. So we do have a backup demo. And that might be why we're hitting a block. Let's try one more. Create a tic-tac-toe game and see how that goes. So once again, you can just modify this. We've included some examples at the top of like creating a website portfolio with Node.js and Vue. And then this can all run directly on your machine. And so once it's done, we'll be able to see some example code at the bottom of how to run the actual file, get set up. And we're going to open that up in VS Code. And so first, I'm just going to open this, and I'm going to let the container build while I'm talking about it. And we can explore some of the files. So you're going to open a VS Code and hit reopen in container. And it's going to start building this in the background. The files that are here, it's generated a devcontainer.json, which is saying, hey, VS Code, install ms-python, the Python extension for me, and then install these requirements.txt, and run this Docker file. I want you to set up Ubuntu, and I want you to install Python and these packages inside of it. And then it's also created a helpful launch.json for us to debug, and a readme and requirements.txt to install the pip packages that we need. And so now that is done set up, you can see it's installed Pygame. It's installed the things we need. I haven't yet touched anything or typed any code. And if I go down here, we can zoom in and see that it has installed the Python extension for me. And all I need to do is hit F5. And we're going to see what the AI has outputted for us. And it has outputted a tic-tac-toe game. And let's see if I can force a win. And I get a cute player one wins output here. So this is just a way that we are exploring and seeing the ways that we can help empower you with AI. I've personally used this project for things like someone mentioned to me, hey, Julia is a cool programming language. And I said, I have no idea how to install that. I want to save myself an hour of time of grabbing those packages and knowing where to do it and put it on my machine and then uninstalling it. Instead, I just typed in, create me a project to learn more about Julia. So we hope you try this out and let us know what you think. Jumping back to the slides. We would love for you to learn more about all the things that we talked to you today about the Windows subsystem for Linux. That includes links to our documentation. You can learn more about all the things we talked about. The WSL issue repository at github.com/Microsoft/WSL is the best place to file your technical issues. Pierre and I literally look at it once a week with the entire dev team.
Yep.
And mirrored networking in WSL, you can learn more about that on our docs page, as well as the Hyper-V firewall documentation, WSL plugin docs. And at the bottom two links, you can see that the WSL Dev Home extensions plugin from the Whitewater Foundry repo is available. You can download the extension today to try it. In the future, we're trying to make it out of box with Dev Home. And then the Quick Start Playground feature is available for the documentation there for you to get started as well. Thank you very much for tuning in. Thank you for being a fan of the Windows subsystem for Linux. And we'll be happy to take any of your questions. Thank you.
Thank you.
Awesome, yeah. Let's see if we can grab help.
I have a question about the networking mode. Can we expose multiple virtual functions in WSL?
What do you mean by virtual function?
The SRIOV mode that's supported in Hyper-V. I think it's called accelerated networking mode.
Yeah, that's not something that we have support for right now.
But what would you be interested in using with that?
So using a single NIC in multiple WSL instances.
OK, interesting. I would love to learn more about it. If you can grab me to LID today or later, I'll be at the WSL booth. I'd like to learn more about the scenario that you have in mind.
OK.
But thank you. Thank you for the question.
Yeah, I think we had a question at the front.
Last one, probably.
All right.
So a lot of the stuff that you showed was really amazing. And so knowing who I am, my question is, do all of these features work on ARM?
Good question. I'm trying to give you a really concrete answer. So when all of these features, there are a subset of features that are different on ARM, and we're working to close that gap. And so WSL does work great on ARM. I know that mirrored mode networking works on ARM. DNS tunneling works on ARM. The stuff that we've showed today, like the dev home integration, Quick Start Playground, works on ARM. Why we're trying to make sure we give you a really good answer is because the Quick Start Playground, for example, things like OpenAI, ChatGPT assumes x84 or x86 a lot more than it assumes ARM. And so there are scenarios where there are little differences that you might get hiccups like that. But what we've shown today does work on ARM.
Awesome. Thank you.
Out of time.
All right, that was the last for questions. Thank you. If you want to come, you can grab us up front. So thank you very much.